To complete our discussion on the payoff and the outcome obtained by the king, if you remember, we saw in the previous video the payoff that he gets when he is able to stick to the promise and is not going to deviate from his promise, and instead the one that he gets when there is a cheating, when the promise made by the king is not fulfilled, is not kept. Now, the level of expropriation that is going to be sustainable will come out basically by comparing these two utility function, these two utility values that he gets under the two conditions. The one where he sticks to the promise and therefore is going to take a share of the national income throughout his life, and the one where instead the cheating comes in. Now, if you compare this to expression, I'm going to write it here. You're going to have T star divided by 1 minus delta yt hat plus delta divided by 1 minus delta times z. And so we're going to have tau hat y t hat none smaller than y t hat times 1 minus delta, we do all the multiplication, plus delta z. We can cancel out one part here and there, and so we're going to have tau hat none smaller than 1 minus delta plus delta z divided by yt. Now remember that y of tau, sorry, and I should remove that. Y of tau is going to be equal to x of tau income produced plus natural resources. You can substitute this one in here and you will get the final expression. What can we say about this? We say that, first of all, tau is decreasing in delta. So as far as the discount factor increase, the level of expropriation decrease, and tau also increases with z. So the higher is the amount of natural resources, and the higher will be the probability of expropriation. As we said before, let's comment on this, and then we go into, or maybe, let me do that here straight away. Let's find out how can we say about the decreasing in delta and the increasing in z. Let's do it here. In order to check that this is correct, that these results are actually correct, we can derive this expression with respect to delta and with respect to z. I'm going to do it here. So if we derive the expression of tau star with respect to delta, we're going to have minus 1 plus z divided by z plus x of tau, which is going to be equal to, by doing the multiplication, minus x with respect to tau plus z, plus z divided by z plus x of tau. We simplify this, so as we can see, because X and Z are actually positive with the minus in front, that will give me a negative value with respect to Z. And with respect to delta. Let's do it now with respect to Z, and I'm going to calculate it maybe here, which is actually a little bit easier with respect to Z, and this is going to be given by delta times Z plus X of tau minus Z divided by Z plus X with respect to tau squared. And is actually, because these are all positive terms, this is a square, we have a plus here, so this is going to be strictly positive. Now, let's have a look to the intuition of these results. As we said before, delta actually measure the importance of the future income to the king. You can think about it to the probability of an institution to stay in place in the long run. So an impatient king, one that wants everything right here and right now, that might not know, think about another institution, whether a politician could be re-elected in the future. If delta is close to 0, I only do care about the, I only do care about the current income. And therefore, I set a very high rate of expropriation. If you look at the expression above, if I set delta close to 0, basically I will get tau. So with delta equal to 0, I will get tau basically equal to 1. Okay, so everything right here, right now. If I'm a very patient king instead, so I have a delta equal to 1, I value the future. And therefore, my promise or whatever I'm going to say in terms of probability of expropriation is going to be credible. If you set now delta equal to 1, as you can see, these terms disappear. This term cancel out, and I'm going to have the outcome produced, which is given by Z over YT. Now, if you think in that way, let's have a look now to the value of natural resources, Z. Remember that Z, natural resources, is the income that is going to obtain if he deviates. And so in the long run, the farmer reacts to this behavior by not exerting any effort and not producing anything else. Of course, the higher is Z, the harder is to commit. Higher will be the higher will be tau as well. Why is that? Think about the African countries, think about Congo, for example, that we know has a lot of natural resources, mines, diamonds. So when you know as a governor, as a policymaker, as a king, if you are in a dictatorship, that you can rely on lots of natural resources that you can sell straight away, you don't have much to concern about what's going to happen when it comes to production. Because the outside option, in some sense, is still very valuable and profitable. So the higher is Z, the higher are the natural resources available to the country, the lower will be the incentive for the king to keep it quiet, keep it low, and set a low probability of expropriation. Of course, if Z increases such that is very much similar or close to 1, then the level of expropriation was going to be approximately equal to 1 as well. And why is that? Because the farmer knows that he cannot punish the king. So whatever the king decides, because of the bargaining powers, that is very much relying on the principal in this case, which is the king, and the farmer does no third party that can enforce deviation from the contract. The king can do whatever he wants, and therefore it sets the level of expropriation as high as he wants. How do I set a formal institution then? Suppose that the king cares about the population, so that suppose that he assigns a wage to the utility, a positive wage between 0 and 1, for example, to the utility of the farmer, which we know is going to be given by 1 minus tau times the income produced, so the probability or percentage non-expropriated of the entire national income, minus the level of effort to produce E. Assume for simplicity now that we don't have natural resources, so that Z is equal to 0. Therefore, the national income is going to be given once again by only X of tau, only income produced, that we know is a square root of the level of effort times A. Now, if we are in a static model without commitment, what the utility function now maximized by the king, is going to be given by how much does he care, does he value, does he get from the expropriation, tau, of the entire national income. But now we add an extra component, which is given by how much does he value the income of the farmer. So lambda times the income or utility of the farmer. Let's say that in this case it is an altruistic king. In this case, if we do this maximization, and I'm going to do that in a separate video, because it takes a little bit of steps that I don't have room to do it here, and I want to do it properly for you guys. So we're going to see that we can still have full expropriation rate, and in this case, as you can see already here, level of tau that the king is going to set will be a function of the value of lambda. The more I care about the population, the lower will be the level of expropriation that I'm going to set. Consider now instead a fixed rate of expropriation, E tau hat, and a level of effort as a function of 1 minus tau times A divided by 2 squared. So the level of expropriation, the optimal level of effort that we calculated before, but now for a given level of probability of expropriation tau. Again, the farmer can introduce a Grimm trigger strategy. I set E equal to 0 forever if the king doesn't stick to what he has announced or established, published publicly, tau hat. If the king commits, his discounted payoff now will be given by exactly as we saw before. The utility function, which is a weighted average in some sense of what he cares for him, how much does he care for himself, and how much does he care for the farmer, for the population. But now this has to be discounted. We also know that if it deviates from the level announced tau hat, and if set instead tau equal to 1, the discounted payoff will be given by that. So he gets the y of tau minus how much does he care about the farmer times the level of effort. Why? Because this part here basically cancel out, because it takes everything. So if you substitute in this equation here tau equal to 1, you will get exactly that. in order to find the level of tau that can be sustainable in this situation, where he cares about the population as well, we have to do exactly what we did before, which is compare the payoff that he gets when he doesn't cheat compared to the one that he gets when he deviates from the announced probability of expropriation tau hat. And this is what you are going to obtain. Now, as you can see now, the value of lambda directly affects the level of property right protection that the king can credibly commit to. Lambda now is a parameter that directly influences the level of expropriation. The higher is lambda, the smaller is tau. The more I care about my population, about my citizen that I rule on, the lower will be the probability of expropriation for taking away things from them. So the conclusion that we can take from this is that when the king, when the policymaker, when the authority, when the government is concerned about the population welfare, it will be able to set up better institutions. And this is a general principle that I would like you to remember, because this is the even with this very simple model, we can show that when I do care about the population as a policymaker, I can set up a different level of expropriation, therefore a different kind of institution on which, for example, citizens can rely on. You will see in the next part of the module that different type of institution gave life, in some sense, produce completely different society and produce completely different level of growth. The recent theory that we have announced at the beginning, the series of papers that I mentioned to you that you will do with Abhishek, Acemoglu, Robinson, and Johnson's paper, are able to show you that the reason why we observe in the world today different rates of growth among countries. Some countries that grew at a very fast pace compared to others that are very much still under development. It's not due to the lack of input, it's not due to the lack of technology, but it actually due, or let's put it in that way, once you have taken into account all these elements, still there is a big portion of the variance that cannot be explained. And the way in which they explain that is by looking at the different type of institution. So different type of institutions can generate different type of growth. What you will learn in the next part of the module is why countries do have different type of institution, why some countries are democracy, why some countries are dictatorship instead, or at least one of the popular version at the moment, or friendly version of the moment, of why this has been created. I hope you like this, you have enjoyed this module, this theoretical explanation of why different kind of institution can change, by changing incentives, can produce different results in terms of productivity and in terms of long-term growth. In the next video, we're going to analyze and we're going to find out how the optimal level of expropriation can be found under the assumption that we have a caring type of king for his population. Okay, let's now have a look to how we create a formal institution. We start by considering the level of income, tau, y of tau, which is equal to x of tau a times square root of e. And we know that the king maximizes tau of lambda equal to the value that maximizes tau times y of tau plus lambda 1 minus tau times y of t minus e of tau. Now, subject to the usual level of effort provided by the farmer. Okay, so first of all, we re-elaborate a little bit the utility function of the king. So we can rewrite tau y of tau plus lambda 1 minus tau y of t minus e of tau. And if we do the multiplication, we get tau plus lambda 1 minus tau square root of e times a minus lambda e. Sorry. Okay. So this is the function that we want to maximize. So we derive, so this is our objective function. We maximize our objective function with respect to tau. So what do? We start by taking the derivative, and this is going to be given by tau plus lambda 1 minus tau times 1 minus tau a squared divided by 2. Remember, this is what e is actually equal to, minus lambda, again, 1 minus tau, substituting by e. And so this is what we get. Now we can arrange, this is all about arranging now. So we get tau minus tau squared times I squared divided by 2 plus lambda 1 minus tau squared times a divided by 2 minus lambda 1 minus tau times a divided by 2, or everything squared. And this is going to be given by 1 minus 2 tau a squared divided by 2 plus lambda 2 tau minus 2 a squared divided by 2 minus lambda, we have 2 minus a divided by 2, this 2 cancel out, times 1 minus tau times a divided by 2. Keep just one step, and then we're going to have a squared divided by 2 times 1 minus 2 tau plus lambda 2 tau minus 2 plus lambda times 1 minus tau which eventually can be written as a2 squared divided by 2, because remember that all this expression is actually equal to 0. And then we have 1 minus 2 tau minus lambda 1 minus tau equal to 0. So this can be cancelled out, and we end up having 1 minus 2 tau minus lambda plus lambda tau equal to 0. Which eventually is going to be equal to and this is the optimal value of lambda that you might get. As you can see now, this is a function of lambda. And if we set lambda equal to 0, so in a case where I do not care about the farmer or my population, I'm still going to get a level of expropriation which is equal to 1.5, which is basically provide us with an equal split. Why is that? Because at least in this case, I can benefit of the output produced. If I care a lot instead about the population and I substitute lambda equal to 1, in this case, I'm going to have tau equal to 0. So the more I care about the population, the lower will be the level of expropriation that I'm going to set.